Hi everyone. In this lesson, we are going to talk about graphing absolute value functions. This is the last lesson in the absolute value packet notes for the Algebra 1 enrichment program. So after this lesson, we'll probably meet in about a week and a half or so to start reviewing for your test. Please make sure that you start reviewing things or come in to see me if you need help. Okay, you will need for this lesson your notes open to page 16. And your graphing calculator opened. I'm going to show you how to graph absolute value functions by hand and how to check them using the calculator. Okay, so an introduction here, okay? Some of this is typed for you and some of this I want you to fill in. The standard form for an absolute value function is y equals a absolute value of x minus h plus k. So what I highlighted in green, I want you to underline or put a box around. That is always the standard form that we need, okay, for the absolute value functions. Okay, so let's take a look here at how to find certain coordinates, and then we'll graph the standard absolute value function. The vertex, okay, is h, comma, k, okay? The vertex is h, comma, k. Since this h up here is negative, the h is always going to be the opposite of what it is in the equation because the standard form is a minus h. So keep that in mind as we go through some examples. The vertex on the absolute value function is the lowest or highest point. I want you to put a point on your graph at the origin, okay, on the graph to the right, and we're going to label that vertex. Okay, I'm going to show you the parent function, which is just the most basic absolute value function. So that's our vertex. The x-intercept, you plug 0 in for y and solve for x. So for the x-intercept, plug 0 in for y, solve for x. If it's an x-intercept, it's going to cross the x-axis. All of these graphs do not have to have an x-intercept. Okay, there will be times when there's not one because you can't solve for it. And I'll show you what happens when there's not one. Y-intercept, you plug 0 in for x and solve for y. So for a y-intercept, the graph will cross the y-axis. Okay, the ordered pair for the y-intercept is always 0, comma, whatever y is. So let me put this for you. 0, comma, whatever the y-intercept is. And for the x-intercept, the ordered pair would be whatever the x-intercept is, comma 0. Okay, the slope, okay, this is kind of interesting. For the right-hand side of the absolute value function, I'm going to put a right here. So for the right-hand side, the slope, which is m, is going to be a. Going back to the standard form equation, the a that I just circled, that is always the slope. For the right-hand side, it's always whatever a is. For the left-hand side of the absolute value function, the slope is always the opposite of a. So m is equal to negative a for the left-hand side. And I'll show you that when we get to the parent function here. Okay, one more that I want you to add if you have room is the reflection point. Okay, so the reflection point is 2 times the h of the vertex, comma, the y-intercept. The reason that an absolute value function has a reflection point is because the graph is symmetrical. If we were to fold the graph over, okay, and kind of cut it in half, it's going to be the exact same on both sides. So let's go back to our graph here, okay? The parent function is y equals the absolute value of x. In front of the absolute value symbol is a 1. So we know, going back to our slope, if a is the slope is 1. So on the right-hand side, we would go up 1 to the right 1. up 1 to the right 1. My smartboard's off a little bit here. Up 1 to the right 1, okay, etc. We could keep going. The opposite side, it's going to be negative, okay? Now, because it's negative, this line's going down, so we're going to the left 1, up 1, to the left 1, up 1. So if we connect these, let me show you what happens. Looking at this equation that I'm drawing a green line on, it goes down 1 to the right 1, down 1 to the right 1. That's why the left-hand side, okay, is going to have a negative slope, or in other words, the opposite of what A is. The right-hand side over here is going to be positive. Up 1 to the right 1, up 1 to the right 1. This is our most basic absolute value function. And if you think back to chapter 9, this is always a function. Okay, so the vertex, the x-intercept, the y-intercept, the slope, and the reflection point, I'm going to show you how to find with some examples here. Before I do that, I want you to take a look at your calculator. Let me show you how to type in absolute value so we can check our graphs as we're going. Once your calculator's on, go to the y equals screen, and I want you to type in math, so the math button. Go to NUM, which is number. Number 1 is ABS, which stands for absolute value. So if you hit enter, okay, it comes up with brackets. If you have an older calculator, it comes up as ABS with parentheses. I'm just going to type in an X, and then I'm going to hit the right arrow, because we just want to graph the parent function, which is the normal absolute value function, y equals absolute value of x. Hit graph, and I think I'm in the wrong form. If your graph looks like mine, hit zoom 6, and it'll take you back to the normal screen. So there we go. If you look at the graph here, and then the graph that we drew in our notes over here, they are exactly the same. That is the most basic absolute value function that you're going to see. Okay, let's go back to our notes, and then we'll come back to the calculator. Okay, let's do the first example together. Okay, I'm going to make this graph a little bit smaller for now so I have room. Okay, so I'm going to go in order of the points we just talked about. Okay, so we're going to start with, I'm going to do actually instead of an A, let's do a number 1. We'll find the vertex first. Okay, the vertex is always H, comma, K. Okay, our parent function, or our standard form, is y equals A, x minus h plus k. So the vertex is always H, comma, K. Remember, here's the H. That standard form is always minus, so that H is 2. The K right here, since the standard form is a plus, that 5 just gets dropped down. Okay? So we're going from the standard form, we're pulling out the H and the K. Okay, so in other words, the H is always the opposite of what's here. Instead of a -2, we have a +2. Okay, so there's our vertex. Let's plot that first. It's either the lowest or highest point on the parabola. Over 2, up 5. So 1, 2, 1, 2, 3, 4, 5. So here's our vertex. Okay, number 2, let's find the x-intercept next. So I explained to you to find an x-intercept, you put 0 in for y. So 0 equals absolute value of x minus 2 plus 5. This takes us back to the absolute value equations that we did 2 videos ago. Remember, you cannot have absolute value of a negative number. So if we try to solve for x, first thing we do is get it into the standard form of an absolute value equation, which is ax plus b equals c. So we subtract 5. We have -5 equals absolute value of x minus 2. So you should ask yourself then, well, can I split this up? I hope you say no. You cannot take absolute value and get a negative number. So what I just circled here, this -5, you can't have that. You can't have absolute value of something that's negative. So you're going to write down here no solution. Okay, there's nothing you can find to plug in that you're going to get a -5. What that means in regards to the graph is that there's not an x-intercept on these. Your graph is not going to cross the x-axis. Okay, so let's see if there's a y-intercept. Okay, to find the y-intercept, you put a 0 in for x. So we have y equals absolute value 0 minus 2 plus 5. So we're putting a 0 in for x, we're solving for y. 0 minus 2 is -2. So we have absolute value of -2 plus 5. The absolute value of -2 is +2. 2 plus 5 is 7. So we know our y-intercept is 7. To write that as an ordered pair, we plug 0 in for x, and we know y is 7. So we have 0, 7. So let's plot that on our graph. Remember, that's going to be where the graph crosses the y-axis. Okay, so 0, 7, 1, 2, 3, 4, 5, 6, 7 is way up here. Okay, so there's our y-intercept. Okay, the next thing that I want to do is let's do our reflection point next, and then we'll come back to the slope. Okay, and my smart board's a little weird here. Our reflection point to find this is always 2h comma the y-intercept. In other words, 2 times the h of the vertex comma whatever the y-intercept was. So 2 times h is 4, because 2 times 2 is 4. The y-intercept is 7. So 4 comma 7 is the reflection point. Remember, since the absolute value function is symmetrical, it's going to be the same on both sides. So go over 4, 1, 2, 3, 4, up 7. 1, 2, 3, 4, 5, 6, 7. So up here is our reflection point. I'm going to connect these, but we're still going to talk about slope. Okay, so there's our absolute value function. Let's make sure that this is true with what our slope is. Remember, the slope is the a value. Okay, on the right-hand side, it's whatever a is. So I'm going to put an r. M is 1 because there's a +1 here on the right-hand side. The left-hand side slope is always the opposite of a. So m is going to be -1. Well, let's see if this works. Okay, if we go here from this point to this point, we go up 2 over 2, up 2 over 2. Okay, 2 divided by 2 is 1, so that's true. If we look at the left-hand side equation, going from this point to this point, we go down 2 to the right 2. Okay, yes, that's -2 divided by 2, which is -1. So you get a slope of -1 for the left-hand side. So the slope, you don't necessarily always need that. It's just a good way to check to make sure that your function is correct. Okay, so that's your first example of graphing an absolute value function. Now let's go to our calculator so I can show you how to check it to make sure that that's right. So go back to the y= screen of your graph. Clear what's there. Let's type this in. Go to math, number, absolute value, which is number 1, hit enter. We're going to type in x minus 2, hit the right arrow, and then plus 5. So it looks just like the example. Hit enter, and there it is. Another good strategy, if you're not sure by looking at the graph if it's the same as what we just graphed, I would hit the second table button to check your points. If you scroll down at the 2, 5, that's the same as our vertex. So if you just jump around here, make sure the ordered pairs are the same as what you found. Even if you go down to the reflection point, 4, 7 is what we got for the reflection point, and that's what it is in the table. Okay, and we could keep going with this. So either second graph to look at the table, or just graph to visually make sure that it's the same. Okay, let's do another one. Let's do letter B, because this one is very simple, but it's a little confusing because it's different. All right. So like we always do, let's start with our vertex. Okay, so the first part, vertex, which is always h comma k. Now, this is technically a plus 0 because there's nothing after it. And inside the absolute value symbol is also x plus 0 because there's nothing there. So the h and the k are both 0 in this one, and that's okay. That means our vertex is down here at the origin. So plot as you go. Let's find our x-intercept. Okay, to find an x-intercept, we put 0 in for y, and we solve. So to get rid of the 1/4, which is the first thing you should do, remember to get rid of a fraction, we multiply both sides by 4. It's going to cancel on this side. 4 times 0 is 0. So we have 0 is equal to the absolute value of x. Now, you can take the absolute value of something and get 0. So at this point, just like we did with the absolute value equations, we split them up and get rid of the absolute value symbol. Now, of course, they're both going to be 0. So our x-intercept is 0, 0, which is the same thing as the vertex. That's going to happen sometimes where you have ordered pairs that are the same. That's okay. Okay, let's go to the y-intercept. To find the y-intercept, we put a 0 in for x. So we have y equals 1/4 times the absolute value of 0. The absolute value of 0 is 0. 0 times 1/4 is 0. So we know our y-intercept is 0, 0. We have another origin here. That's our answer for the ordered pair. And again, that's okay. Okay, let's go to let's go to the reflection point, sorry, and then we'll go to the slope. Our reflection point, okay, is always going to be 2h comma the y-intercept. So you probably already realized 2 times the h of the vertex, remember that's the h of the vertex, is 0, and we know the y-intercept, which we just found, is 0. So there we go. It's another point that we've already plotted. Now, the slope is going to be very, very helpful in this one. Okay, so let's do the right-hand side first. The slope of the right-hand side is always what this a value is. So m is equal to positive 1/4. Okay, it's always equal to what the a is. So let's graph that first. Going from the origin to the right-hand side, our rise is 1, our run is 4. So up 1, 1, 2, 3, 4, to the right 4. So there's where our first point will be. Up 1, 1, 2, 3, 4. If I could go further, it'd be way over here. So that's the right-hand side. I'm going to connect them. Okay, now the left-hand side, the slope is always the opposite of a. So it would be negative 1/4. Okay, now our line's going to go down from left to right. Okay, so we're kind of going backwards with this. Okay, so we're going, let me plot this here. Our rise over run from this point to the next, okay? We went up 1, and then we went to the left 4. So you have to try to think of this as we're graphing it backwards. If I go from this red point to the origin, you go down 1 to the right 4. Okay, down 1 to the right 4. Basically, it's symmetric, okay, of the point that we already graphed on the right. So it's going to be right across. So if we do it again, we still go up 1, but we're going to the left 4. So it's kind of like saying, let me cross this off, that it's 1 over negative 4, because you're still going up 1, 1, 2, 3, 4, but you're going to the left 4. So hopefully that makes a little more sense, okay, with the left-hand side. But again, if you check, I would go from this point to this point, just like we graph in class, down 1 to the right 4. Excuse me, down 1 to the right 4. Okay, so that is an example of a problem, where the slope is very helpful. Okay, let's do one more of these together. Let's do letter C, and I'll go a little bit faster on this. Okay, letter C. Okay, let's start with, and if you want to go ahead, go ahead. Let's start with our vertex. Okay, letter C is different because instead of the inside of the absolute value symbol being a minus, it's a plus. Remember, for the H, you always have to take the opposite of it. So our H in this one is -1, and that's because our standard form is A and then absolute value of X minus H plus K, comma, the K is -2. The K always gets dropped down. This one is always the opposite. Okay, so let's plot our vertex. -1 down 2, 1, 2. So here's our vertex. It's the lowest or highest point of the absolute value symbol. Okay, let's go to our x-intercept. X-intercepts, okay, to find these, you put a 0 in for y and solve. So 0 equals -3, and then absolute value of x plus 1 minus 2. So to get this in the form, before you split it up, we add 2 to both sides. You get 2 equals -3, absolute value of x plus 1. And then we divide both sides by -3. So we have -2/3 equals the absolute value of x plus 1. So you ask yourself, can I take the absolute value of something and get -2/3? Okay, you cannot. So there's no solution, which means just like the previous, or the 2 examples ago, I should say, you do not have an x-intercept here. That's okay. That can happen. Okay, so this graph is not going to cross the x-axis. So let's go to our y-intercept and see if we find a y-intercept. To find a y-intercept, we plug 0 in for x. So y equals -3, absolute value of 0 plus 1 minus 2. Okay, so y equals -3, 0 plus 1 is 1, minus 2. -3 times the absolute value of 1, which is 1, okay, we get -3, minus 2, which is -5. So y-intercept is 0, -5, so yes, we do have one. So if we go to graph that, over 0, down 5, 1, 2, 3, 4, 5, down here. Okay, so there's our y-intercept. It's where the graph crosses the y-axis. Let's go to number 4. Let's find our reflection point. Okay, our reflection point, okay, is 2 times h. So 2 times the h of the vertex. So we get here 2 times -1 is -2, comma, the y-intercept. The y-intercept is -5. So if we go to plot this, we go over 2 to the left, down 5, which is right here. So 2 to the left, down 5. Let me connect these. Here's another example of the graph when we really don't have to find the slope, but I still want you to, just to check and make sure that your graph is correct. So the slope for the right-hand side of the function would be what a is, which is -3. So if we go and check this, going from the vertex to the point on the right, you go down 3 to the right 1, down 3 to the right 1. So we know that one's right. The slope on the left is going to be m is equal to the opposite of what a was. So the opposite of what a is +3. So if I look at the line on the left here, I just made it in green, we go up 3 to the right 1, up 3 to the right 1. So that is correct. We know our slope is a +3 on the left, -3 on the right. The left-hand side graph is increasing. The right-hand side of the function is decreasing. Okay, this is an upside-down absolute value function. We would call that concave down. Okay, I want you guys to try letter D on your own. So if you want to pause the video and do it now, you can. If not, keep watching and then come back to it. All right, let's do, I think I want to do 1 or 2 more examples. Okay, let's go to letter E. Okay, letter E, this part's a little bit easier, at least I think. Okay, we now are going from a graph to an equation. So I want you to write down the standard form, which is y equals a, absolute value of x minus h plus k. Okay? Very important here that you find the vertex and the slope. That's all that you really need to find is the vertex and the slope, okay? And it's, again, it's pretty straightforward because you already have the graph there. Here's your vertex, okay? Remember, it's the lowest or highest point of the absolute value function. So if you figure out that ordered pair, it's over 3, up 0. So our vertex is 3, 0. Now you need to find what the slope is. So if we go from the vertex and we look at this right-hand side, because that's always what A is. It's the same as whatever the right-hand side slope is. Up 1 over 1, up 1 over 1, up 1 over 1. So we know for the right-hand side, I'm going to put an R up here, that the slope is 1. Okay, and if it's the right-hand side, we know that that means in standard form that A is 1. The vertex, don't forget, is always H and K. So let's plug in what we have, okay? Y equals, the slope is 1, absolute value of x minus, remember, plug the h in, it's going to be 3, because we know that that h is positive. It's always the opposite of the standard form. Okay, so it's x minus 3, even though this is a positive 3. And then end your absolute value. The plus 0 you can have there, but you don't have to. Just like this 1. So if you don't like having those 1s and 0s there, you could just write it as y equals absolute value of x minus 3. Now, if you want to type this into your calculator to check, feel free to do so. Okay, if you type that in, actually, let me just do one more of these with you. Let's type that in. Okay, let's go back to our y equals. I'm going to clear what's there. Go to Math, Number, ABS. Type in x minus 3. Hit the right arrow. And then graph. There it is. And you could even go up and hit second graph to look at your table. Okay, let's do one more of these. Let's do letter F. Okay, so letter F, I'm going to do the same thing. I want you to write up here again this standard form, so you get really good at memorizing, or maybe you already have it memorized, what the standard form of an absolute value function is. When you're going from a graph to an equation, I would always find the vertex and the slope. Okay, the vertex, which is always h comma k, is right here. Over 0, down 6. Okay, now if we look at just our right-hand side, we need to find the slope. Up 1 over 1, up 1 over 1. Okay, this is kind of boring. Our slope, which is m, for the right-hand side is 1. So since it's 1 for the right-hand side, we know that the a is 1. So let's plug into our equation what we have. Y equals 1, so that's the a, which is our slope. Okay, absolute value of x minus h, which is 0 in this one, plus k, but since the k is negative, it's minus 6. So if we simplify this further, we don't need this 1, and we don't need this 0. So it's y equals absolute value of x minus 6. Makes this look a little bit nicer. And remember, this is very similar to the basic parent function, but you just shift the graph down 6 units. Okay, so I'm going to stop with that example. So I want you guys, in addition to letter D, I want you to do letter H. Actually, I want you to do, in addition to D, letter G, H, and then on the back, letter J. Okay, the word problem is pretty easy, so I'll say those again. Do D, G, H, and then on the back, letter J, which is an application problem to this. So this ends the graphing absolute value function lesson. Okay, please see me so I can check over the 4 problems that you're doing on your own, okay, and so I can give you the assignment for this. Please make sure that you're prepared for a review for this whole packet in about a week and a half.